Okay, so I'm having to record this video the second time because the first time I actually I forgot to put the microphone on me and it wasn't even turned on. So I'm gonna wear it now and I'm gonna restart the video. Okay, so I explained this and I'm gonna do it a second time, but you just got to see the second time, which for you is the first time. What I want to show here is that you can use any programming language to do this. I'm going to use Ruby, but like I'm producing an image. It doesn't have any third-party libraries, no requirements at all. So this is the source code for that. I start by declaring the image height, width and height. So it's going to be 301 pixels, and I can vary that value as I want. Like if I put 500, and then if I hit refresh, it's not going to change because I have to come here and run my program. So now I can refresh, and there you go. It's going to generate this image every time I run the program. Is pretty quick, even though it's Ruby. It's kind of slow language. All right, so yeah, you can do it. Like you can just do it. What I'm writing here is a BMP file. So BMP is a very old format. I'm guessing Microsoft invented it. I don't know. I don't think that's so important to know. But the fact is, it is a very simple format. So what is going on here is that I'm writing 3 sections of bytes. So it's a binary file, of course. And I'm writing 3 sections of data here. So this, what I'm calling like a tiny header, and then a proper DIB header. And then down here is going to be the actual pixel data. So no more headers, just the pixel data. Okay, the DIB header is important because it's going to contain the image width and height information. And there's going to be also some other information like this 40 number here is going to say how long, like the size of this header in bytes. So this header is always 40 bytes long. And then next comes the width and the height encoded as L's. So these L's right here are encoding all this data. So L stands for long, which is a 32-bit or 4-byte integer number. And S is short, so it's half long. So L, each L here is writing 4 bytes of data. Each S is writing 2 bytes of data. Yeah, 16 bits number, those are 2 bytes long. So 40 is the size of the header, and then the image height and width and height. And then this one, I don't remember what it is, but I guess it's just like image type or something like that. And then 24, I also don't remember, but I would guess is like pixel format. So 24 is like 24 bits per pixel. And 24 bits, you can divide it in 3 components. It's going to be 8, so 3 times 8 is 24. 3 stands for RGB, so red, green, and blue components of each pixel. And each component has 8 bits, which 8 bits can store a number between 0 and 255. You can see these numbers 255 down here because that's the range of each pixel. I mean, that's the range of each pixel component, okay? So you can already see here RGB, these are the color components of each pixel, and they go from 0 to 255, 0 meaning a black color, and 255 meaning a white color. If you're going to get full white, you're going to set all 3 components RGB to the maximum value, 255. If you're going to get a black pixel, you're going to set all 3 of them to 0. If you do something like I don't know, our red and green is 0, but blue is like 255, you're gonna get full blue color. So that's for instance, this bottom left component here is full blue. It doesn't have any other component. This right here is full green and full blue. So it's going to be like this bluish color. And this, in this particular example I'm doing here, I'm always setting the red component to 0. Let's see if I change it to 50 and I just reload it here. Yeah, it's going to be a little bit more reddish. Okay, and then there's violet going on here. Can you see that? Anyway, I was explaining the header and then I jumped to the image. Anyway, so 24 bits, that's a component for the pixels, okay? So D0, I have no idea what it is. I think the documentation said that it always has to be 0. This was supposed to be an image size, but nobody cares. Like, no viewer looks at this. Like, no, by viewer, I mean like I'm viewing this file in Google Chrome. So Google Chrome is the viewer. If I go to my Mac OS thing here and I hit it right here, that's the viewer. So the Mac OS viewer, which is reading these BMP bytes and interpreting the file and displaying it as an image in my display. I want to make sure I'm recording, and I want to make sure that I have audio because I did this once already. Okay, 72 dpi, so it is like dots per inch. I don't think anyone is looking at that. I guess if I change it to 1 and regenerate the image, let me do that. Nobody cares. Look at that. Beautiful. If I open it here, same thing. Okay, so nobody actually cares about that. I don't know. I'm going to write 72. It's kind of like standard DPI for monitors. And then these 2 zeros here, I have no idea as well. So the only part that matters here is the image dimensions. Okay? And then before this header actually is written, I have to write this tiny header. I call this tiny header. Nobody else, I think, calls it like that. So the first 2 bytes of the BMP file is going to be BM, which I guess stands for bitmap. And then there's going to be a file size, which supposedly would be the whole, like the size of the whole file. I'm just writing 0, and I haven't had any issues with that. But if I would to follow this spec correctly, I would actually write the file size here. Then there are 2 zeros, which I don't remember what they are, but it's like they have to be here. And then this last information actually has to be correct, otherwise it doesn't work. I guess if I put like 39, let's see what happens. Oh yeah, Chrome shows a broken image, and macOS also cannot display it. So it has to be correct. What this value is, like, this is like the distance within the file. So the distance between or from the beginning of the file to until where the pixel data actually starts. So what this is actually 40 bytes here because of this header. So I'm considering this whole header is always going to be 40 bytes long. And then 3 times 4 here is going to be this section right here, plus the number itself. It also has to be considered. Okay, so this is writing 4 bytes. L is a 32-bit integer, so 4 bytes. S is a 2-byte integer, 16 bits integer. I cannot say that properly. So 2 plus 2 is just 4, and then this is an L, so 4 bytes also here. So 3 times, these are the 3 times 4 bytes each. And then plus 2, which stands for the 2 bytes here, the B and the M. All right. Yeah, I kind of want to do something nasty. Like, I kind of want to say 42 and then go ahead and write a little bit more data to the file. I'm going to do it right now. If I do write, like, I don't know, whatever. I don't know. I'm just writing the first thing that comes to mind. So I'm going to put 2 more bytes, and then I'm going to have this data here. Like, it doesn't mean anything. It's not going to be read by anyone. I wonder if that works. Okay, Chrome displayed a picture, and macOS as well. That is very interesting. That is very interesting. I'm gonna play with this later a little bit more. But then, yeah, then I have to write this tiny header, and then I write the proper header, and then I go and I begin writing the actual pixel data. So the pixel data is encoded like, and I think this is true for most, if not all, image formats, like PNG, JPEG, maybe JPEG, it's different, I don't know. So for BMP, it is true. It's like you write, like there's an outer loop here and an inner loop. So this inner loop is writing one row of pixels. So from left to right is writing the full row. So the information that's actually getting written is the red and green and blue component of each pixel. So you can easily calculate that the amount of pixels the image is going to have is like the height times the width. Okay, so that's basic mathematics. That's how many pixels we're going to have, and thus that's the amount of times we're going to iterate through this loop. So I'm generating this image as like on the fly as I write them to the file. Okay, I'm not like buffering it beforehand. And that's why it's a very simple image, like just a gradient. Okay, so what I have to do for each pixel, so this code is going to be run for each pixel, and then we are going to write the pixel. The pixel is going to be written as 3 bytes, so C stands for character, so it's going to be a 1 byte. And then you got to write it like BGR, so not RGB, but blue, green, and red in that order. What I'm doing here for each pixel is I'm defining that the red component is always going to be 0, and then green is going to vary from, as you can see here, like from left to right. Okay, so on the left side, the green component is going to start on 0, and it's going to be the maximum value. So like it's very common to say that on the left side, the pixel value for green is going to be 0. And on the right side here is going to be like full green, so it's going to be 1. But actually it's going to be like 0 and then 255. And the reason is like, it's kind of easier to reason like within 0 and 1 boundaries. And like it just so happens on BMP files, it's like 8 bits per pixel that you're going to store, or rather not per pixel, but per pixel component. Okay, so like each of the colors, it's going to be 8 bits. And then if you suddenly get like 16 bits, like an image format that stores 16 bits per component, then this range is instead of going to be 255, it's going to be 16,000 something. So it's going to be a different number. And then if you just say like the values between 0 and 1, like it doesn't matter how many bits there are. So it's just 0 and 1. Anyway, I digress. So B and then blue is like gonna go from like it's gonna do the opposite thing. It's gonna be start like from full-blown blue until no blue at all. Okay. So just by looking at this code, you probably can guess like green is looking at the X component, like the X axis. So it's horizontal. So green varies only on the horizontal axis, not axis. And the blue component varies only on the vertical axis, okay? Because it's looking at the Y variable. So you can see blue, if you look at just like this left part of the image, blue is going from black on the top to full blue on the bottom, okay? So think about it, this black has to be 0, and this full blue has to be 255 in the case of an 8-bit number being stored there. So if you think about the blue thing, I am doing like Y component. So the Y varies between 0 and image height. So this value right here is going to vary from 0 to 1 as the image progresses. But I'm inverting it. So by putting this 1 minus, and then it's going to be like 1 minus a number that is going to itself be a number between 0 and 1. So what I'm doing is that like as Y increases, this number right here goes from 0 to 1. And by adding this 1 minus, it's going to make this whole thing right here vary from 1 down to 0. Okay, so it's going to be like at the beginning of the loop here. And remember, like since Y is varying on the outer loop, these values kind of be the same for throughout this whole internal loop right here. But it's going to vary vertically because it only depends on the y value, which is defined here. And I kind of lost myself now. And yeah, that's it. So it's going to vary from 1 on the beginning of the image. It's going to be full blue, and then times 355, so that number between 0 and 1 is always going to be between 0 and 255. So the value is going to vary from 255 in the beginning of the y-axis, and by the end of it is going to be black. Okay, so it's going to be 0. Just by that information, so in the beginning it's going to be full blue, and then at the end it's going to be black. So you can see from that already that the BMP file is written like at the vertical axis is written from the bottom to the top, which for me is kind of weird. For me, I don't know, I perceive it as being inverted, as I would think that most things in computers are like, they are left to right and then top to bottom. But in this case, just like inverted in the vertical axis, and that's it. So you're writing always, I mean, it does make more sense if you think about a graph, like in mathematics, a graph, the bottom of it is 0, and then as you go upwards, the numbers grow. So in that sense, the BMP file makes more sense. All right, and then with the horizontal axis, it's kind of the same thing, but it goes from 0 on the left side to 1 on the right side, and you can see like it's black on the left and then full green on the right. So this is just like plain left to right here working, and that's it. So beautiful. How do we write the actual pixels? So you can see that I'm going on each row, and then for each row I write the pixels from the left to the right. And then there's a little bit of magic going on here, which kind of sucks, but it is a padding, which appears in many different, I don't know, it appears in different pixel formats, or like things that store pixels, like when you're sending an image to a video card, for instance, sometimes you have to also add that padding, like if you're using OpenGL or something like that. So I don't know why that padding is necessary. I think it's maybe a thing of the past, especially for BMP files. Not so important today, maybe more important when you're dealing with video cards. But the thing is, like, the rule here, and that's why this calculation here, like, that's what it is doing. And that is why I was like testing kind of different widths. So the padding only happens on the horizontal axis, and the rule is kind of like, you calculate like how many bytes per row you're going to have. Like each row is width pixels long, and each pixel has 3 bytes. So that is the amount of bytes that the row is going to have. The thing is, this number has to be like you got to be able to divide it by 4 and get an integer number instead of a floating point number, instead of a real number. And when that does not happen, you need to add padding. So I'm gonna show an example here. Okay, I'm gonna try and do this. I'm gonna open RB. Let's say my image width is 301. Then my bytes per row is gonna be 903. 903 divided by 4 is not a integer number. So this is the problem. Like it has to be an integer number, and that's what the padding is. Okay, so if I put a padding, and let's say the padding, so it's going to be the padding. If the padding is 0 bytes, it's going to be just the same thing. All right. Oh, I need absolute. I need to do this. Okay, so if I add 1 byte of padding, okay, now 1 byte of padding, that's already enough so that this value here, so the bytes per row, is a integer number now. Okay, so it's 0.0. It has to be 0.0. How do I calculate this number? how do we do it? I could do a for loop and keep trying until I get a number that is integer. But this formula here is also going to work. So if I put padding size, I have the bytes per row, 93. So padding size is 1. So this formula calculates that. And then what I got to do is like, I need to write 1 byte after each row just to satisfy this kind of odd condition that the amount of bytes in a row has to be, I don't know how to pronounce that word, so I'm avoiding it. But it is like, it has to be divisible, I don't know, by 4. Okay, you get the idea, right? So I'm calculating these ones because it's going to be the same for like everywhere. And then I'm already buffering the padding into a string, so I can just use file.write on it. And if there's no padding, then I don't write anything. All right, that's good. So that's it. Like, that's how you write a picture. I don't know. I kind of want to do something else here. Okay, I'm not going to play with the pixels right now. What I want to do here is like, I want to show that this BMP file format, it actually has something, I don't know, funny maybe. So if I take a look at the output file size, that is 686 kilobytes. And what I want to show like is I can add random data, so random data, to this file. And I can just like hide it within the file and nobody's gonna see it. I'm gonna put like this WE here, for instance. So I want to write like a significant amount of random data. So I'm gonna write like, I don't know, I don't have to do it like that, but let's say, so this is gonna be already 1 megabyte. So I'm gonna put like, I don't know, 10 megabytes of random data. That's gonna be fun. There's probably a better way to do it in Ruby. I'm just gonna do it like this for now. So I'm gonna do like between 0 and 255 included. So it's gonna be the random data, and this is gonna be the char. So I'm gonna just join it. Let me test it. It's kind of slow. Okay, so doing this is slow, I guess. Well, that's very slow actually. I meant time. So just generating that random data is very slow. Probably if I use widget, it's going to be much faster. Still slow. Anyway, I'm not aiming for speed here. So what I want to do is like, I need this pointer, like this information right here is going to tell the viewer where the actual pixel data begins. And then it's like I'm inserting like weird, like a fake header here, and this header is 10 megabytes long. So I'm gonna replace that with my random data thing. I think I can do it like that. And then, and then I'm just gonna consider, like if I just do like this, it's probably gonna show garbage pixels, but still probably gonna work. So let me do that. And I think it's gonna be like a garbage image. Yeah, just like that. So random pixels, because it's reading from these 10 megabytes of like just random data. If I take a look at the file size, it's gonna be 11 megabytes. So huge file. And then what I actually want to do is like, I want to tell it to skip those bytes when reading the pixel data. Okay, so I'm gonna put the length there, because then it's going to point like where the actual pixel data is. So let me generate that. And then there you go. So the image is there. macOS displays it correctly as well. And the file has 11 megabytes. And I could, if I wanted to, I could put like any data here. Like I could hide a whole file within a BMP file. Yeah, and there's a way, which I was testing before with this commented out code here, to put actual, like, to put any file, like, I don't know, hidden data within the pixel data itself. But that's gonna be for another video. Okay, so see you guys.